Hello, my name is Marcelo. I'm staying in Buenos Aires, Argentina. This is an introduction or a brief approach to the AWS IoT services. I have only 12 minutes to do this presentation, so we must move fast. Let's begin. Almost all IoT solutions involve hardware and software development. The hardware includes a unit process and sensors. The unit process is something like this. This is a microcontroller. It has some input-output ports, analog digital converter, serial port, Wi-Fi. So we can attach a different kind of sensors to it. Sensors like these ones. For example, humidity sensor, photo-optic sensors, pressure sensor, etc. There is other type of sensor called intelligent sensor, where the unit process and the sensors are in the same unit, like this. This is a power meter. We can communicate the microcontroller to it, for example, to read the internal registers, using a serial interface and a Modbus protocol. If you need more process power, perhaps you prefer to use something like this. This is not a microcontroller. It is a microcomputer. In a microcontroller, a firmware runs a program control. Perhaps you install an integrated development environment, and usually you program it in C or C++ language. In a microcomputer like this, the Raspberry Pi, you can install an operating system, for example, a compact Linux operating system, so you can install any framework and can be programmed at any language. Okay, let's see a basic IoT solution diagram. Okay, here we have a unit process, microcontroller or microcomputer, that gets data from sensors. Send this data to the server using some network under some kind of protocol. When the server receives the data, it's stored in a database. The server can also run some process to provide analytics to show the data in a tabular or graphical representation. Let's see this diagram in more detail. Well, we have the unit process, microcontroller or microcomputer that reads the temperature and humidity sensor at regular intervals. Then send this data in a plain text. It can be comma delimited or XML or JSON document. XML and JSON document represent data in an structured way. I strongly recommend you learn read and write JSON documents. We use Internet and MQTT protocol. MQTT is an acronym of Message Queuing Telemetry Transport. It's a lightweight protocol that runs over the TCP protocol. On the server side, we have the MQTT broker. That is a piece of software that implements publish-subscribe communication model. So, the unit process connects to the message broker and publish a message, that is a JSON document, to a topic name. The MQTT broker retains the message until a process connects to the MQTT broker and subscribe to that topic name, receive the message, and store in a document database. A document database, unlike a relational database, is more flexible. In a relational database, when you design a table, you specify column names and data types for each column. But once you define it, you cannot change it. The schema is fixed. In a document database, the document that is equivalent to the row in the relational database can change. The drawback is that you cannot run complex queries or join tables. The server can also run a web server. The web server can execute a servlet to query the document database and present the information in a tabular or graphical representation. Okay, here we add other hardware component to the unit process, but in this case it's not a sensor, it's a relay. So the unit process connects to the MQTT broker and publish on the topic name, for example, unit process -sensors, a JSON document with the values of the temperature and humidity sensors, temperature 25 degrees and humidity 40%. But also, and at the same time, the unit process subscribes to other topic name. For example, server-relay to receive a JSON document that can say, switch the relay on for 20 seconds. So, the communication now flows in both directions, from the unit process to the server and from the server to the unit process. The server process that receives the JSON document can transform it before to store the document in the database, for example, adding a timestamp attribute. Finally, to get metrics, we can use dynamic HTML page. Dynamic HTML refers to include JavaScript in an HTML page. We can use D3.js JavaScript library to build graphs. The graph can be a line graph, a simple line graph like this, can be a pie chart or a bar chart, but also a much more sophisticated and complex graph like this. This graph represents the relations of all characters in the novel Les Miserables of the French writer Victor Hugo. Well, finally, we must consider the security aspect. If your unit process is sending ambient temperature and humidity values, that is not confidential information. But if your IoT solution is sending sensitive data, it must be encrypted. But also, and perhaps more important, the microcontroller must be sure the data came from the server, and the server must be sure the data came from the microcontroller. It can be done installing a certificate on both sides. This certificate can be obtained from a certification authority, like VeriSign, Taute, or other. So, it's simple, isn't it? Unfortunately, I have bad news. Look at this. What do you think is this? Is it the Argentine flag? Do you remember the Apollo 13 movie when Tom Hanks, the actor Tom Hanks, says, Houston, we have a problem. Well, this is not a rocket technology, but we have a problem. Suppose you are designing a large IoT smart city project. Now, you must manage hundreds, thousands, perhaps hundreds of thousands of microcontrollers and sensors. Perhaps you must process thousands of messages by second. In a large-scale IoT project, the things change. The IoT project is basically a scale problem. If you have a few microcontrollers and sensors to manage, it's easy. When you must manage hundreds of microcontrollers and sensors, the problem grows. Not geometrically, grows exponentially. Let's see some issues that must be addressed in a large-scale IoT solution. Well, first, it's no longer possible to install the software manually. We need to find a way to do this automatically. The same applies for the certificate installation. Besides, we need to have a software version in control. Perhaps some microcontroller runs a version and others a different version. In the same way, we need to take care about the server dimension that now has to process a huge amount of data. Finally, how to recognize and what action to take for different kind of failures. If the microcontroller stops to send messages, this is because it is damaged, lose connectivity, is a power problem. If sensor measures are out of scale, what action we will take? In both cases, we need to send an alarm or notification. But how does the server know the last state of the microcontroller when it reconnects? Here is where AWS comes into the picture. Well, AWS is a cloud platform from Amazon that provides services. This is the AWS console. As you can see, there are a lot of services grouped by name and function. For example, compute, storage, analytics, and Internet of Things. Inside, we have the IoT core services. It's important to note that IoT core services from AWS solves part of the problem, but not all. Let's see a diagram of the AWS IoT core services. Well, here we have the devices, that is a microcontroller or microcomputer, the message broker, as we saw before, the device shadows. The shadow is a JSON document that retains the last state known from the devices, but also there is a shadow service that can set to a state for the devices when the device is disconnected. The rules engine that can filter message from the message broker and produce an action. And on the right side, there are a set of other AWS services that help to build our solution but are not part of the AWS IoT core services. AWS provides three ways to connect the message broker. We can use MQTT protocol, HTTPS protocol, or MQTT over WebSocket. Before the device can connect to the message broker, the device must be registered. This process of registration includes get and install an X509 certificate. We can get a certificate from an external certificate authority, or we can get it from AWS. Once you got the certificate, you need to assign a set of policies to it. These policies say to which topic the device can publish and subscribe in the message broker. Note that the AWS message broker is offered as a serverless service. That means that you don't need to deploy your own infrastructure to consume this service. Your device connects to the message broker endpoint and begin to publish or subscribe on a topic. Of course, if your device has the rights to do that. The rules is another service you can use. It has two steps, a filter and an action. For example, you can filter the message received on a topic using an SQL statement, and an action can say that all the message be saved on a document database. For example, we can say select all data from the topic sensor-room 1 where temperature greater than 25 degrees. Instead of installing on-premise document database as before, AWS provides a document database in a serverless mode named DynamoDB. Shadow is also part of the IoT core services. A device shadow is a JSON document that reflects the last state known of the device. The shadow service is used to store and retrieve current state information for the device, regardless if the device is connected or not. You can also instruct the device to perform a software or firmware update using job service. Now, suppose you want to transform a message before it will be stored on the database. For example, to add the timestamp attribute as we mentioned before. In this case, you can add a rule to get the message and pass through a Lambda function. Lambda function is other AWS serverless service. A filter can invoke a Lambda function. The function is written in JavaScript under Node.js or in Python language. The function can inspect the message, transform it, and invoke other AWS service. It's important to note that Lambda functions are stateless. After finish, it doesn't remember nothing. Other AWS serverless service that is not part of the IoT core services, but we can use to send an alarm or a warning, is a simple notification service. You can send a notification via email or SMS channel. Well, this was a short description of the IoT core services. I think I consumed all my 12 minutes I had. Before end, suppose you've worked hard all day and all night to get a great IoT architecture. Tomorrow we'll have the opportunity to present your project to the VP and the CFO. You start. Silence. Nobody say nothing. You think, well, the things are going well. Before finish, the CFO raised his hand to ask. Forget it. No CFO raised his hand to ask. The CFO asked, how much does it cost? You begin to laugh and answer, how much does it cost? Stupid question. Who cares how much does it cost? It's cool. Great project. I'm a fucking genius. wrong answer. Instead, try to combine them with numbers and graphs. They love graphs and numbers. Try to explain how your solution is the most appropriate in two aspects. The only two aspects that the financial VP or CEO understand: saving, profit, and opportunity. Some parts of the solution have a fixed cost, for example, the cost of the microcontroller or sensors, but the other part, the AWS services, the cost is variable and sometimes difficult to calculate. For example, the cost to use the object storage S3 depends on the volume of data and frequently accessed. The DynamoDB service cost depends on how fast you need to write and read the documents. And the Lambda function cost is calculated by time of execution. Take all this into account when presenting your project. Well, fellows, that's all for the moment. These are bad times, I know, you know, but this too shall pass. Better times are coming. Meanwhile, stay safe at home. Thank you for watching. Carpe diem. So long.